Assalamu alaikum students. Today we will study matrix and its application. Right. So first of all, what is matrix? So matrix is the arrangement of information, arrangement of vast amount of information, in an array. Array means, so matrix is the arrangement of vast amount of information in an array. So array means like a room or location, Array means storing information. Array means storing information in particular location, in an organized way, so that we can process those information and come up with a solution. So matrix is very helpful to deal with vast amount of data or information. Right. So now, what a matrix can so a matrix is denoted inside a bracket. So for example, this is a matrix. So this is a matrix. So it can be written inside a bracket, or it can be written inside a parenthesis as well. So it can be written inside a parenthesis as well. So we can write it like this way also. So it can be written as this way also. So a matrix can be written inside a bracket or inside a parenthesis. So we can write it like that way. So it's the same. So let us understand. So what's the dimension of this matrix? So as you can see, these are the elements of the matrix. So these are the elements of the matrix. So what's the dimension of the matrix? So if you are asked to identify dimension of the matrix, so if you are asked to identify the dimension of the matrix, you will write, first of all, you will write it inside a bracket, inside a parenthesis. So remember, so if you are asked to identify dimension of a matrix, first you need to identify how many rows are there. So as you can see, here we have two rows. And we have two columns. So this is a 2 by 2 matrix. Although we will write it like multiplication sign here, but we will pronounce it like 2 by 2 matrix. So that means we will pronounce it like 2 by 2 matrix. So we will pronounce it like 2 by 2 matrix. So that means this one indicates how many rows are there in the matrix. This one indicates how many columns are there in the matrix. So this way we will identify dimension of a matrix. Right. So if you have something like that, we will not call it a matrix. So if you have only one column in the matrix, we will call it column vector. We will not call it a matrix, we will call it column vector. So we will call it a column vector. If you have only one column in the matrix, we will call it a column vector. Similarly, if you have only if you have only one row in the matrix, if you have only one row in the matrix, we will call it row vector. We will call it row vector. So we will call it a row vector because there is only one row. So here we have only one column, we will call it a column vector, right? Now let us identify how we can identify, if we can multiply between two matrices. So for example, we have a matrix P. So P is equal to so P is equal to this one. For example, here we have so this is a matrix. So P is equal to this one, and Q is equal to so Q is equal to, for example, we have 9, 4, 7, 1. So this is another matrix. So this is this matrix is P, and this matrix is Q. So we want to multiply these two matrices. So remember, matrix is singular, and when we will have multiple matrix, we will call it matrices, right? So we want to multiply these two matrices. So multiply or find PQ is equal to what? So we want to multiply these two matrices. So when you want to multiply two matrices, first of all you need to identify dimension of the matrix. You need to identify dimension of the matrix. So now we will multiply matrix P with matrix Q. So before we multiply these two matrices, first we need to identify whether we can multiply these two matrices or not. So to identify whether multiplication is possible or not, we need to identify dimension of both matrices. So dimension of the first matrix, so the dimension of the first matrix is what? That means dimension of this matrix. So first we need to identify dimension of this matrix. So the dimension of this matrix is, we have two rows. As I said before, you need to first identify how many rows are there. So in this matrix we have two rows and three columns. So that means the dimension of this matrix is 2 by 3. So dimension of this matrix is 2 by 3. So this is P, this is the P, this is P, matrix P. Now let us find out dimension of Q, the dimension of Q. So the dimension of Q is, we have two rows and two columns. So that means the dimension of this matrix is 2 by 2. So dimension of this matrix is 2 by 2. So this one identifies we have two rows in the, this matrix has to have two rows. So that means in this matrix we have two rows and three columns, In this matrix we have three columns. So 2 by 3 matrix. Now the matrix Q, in the matrix Q we have two rows and two columns, right? So these are the dimension of P and Q. So remember, if you want to multiply two matrix, number of column you have in the first matrix should match with number of row of the second matrix. So that means these two should match with each other. So that means number of column that you have in the first matrix, that should match with the number of rows in the second matrix. So here we have 3 column in the first matrix, we should have 3 row in the second matrix, but here we have only 2 rows. So I'm saying again, so in the first matrix we have 3 column, but in the second matrix we have 2 rows. These two should match with each other. So if you have 3 column in the first matrix, you should also have 3 row in the second matrix to multiply both matrix. So here this does not match. So that means here number of column in the first matrix is not matching with number of row in the second matrix. So multiplication is not possible, will not be possible. So that means here multiplication won't be possible, won't be possible. So multiplication will not be possible, multiplication will not be possible. So that means here multiplication of P and Q will not be possible, will not be possible, right? So now suppose let us change the matrix Q. Let us change the matrix Q. Suppose this one is this. Suppose this one we have is here like 2 5 1 0 8 2. So this is matrix Q. Now as you can see, if you want to multiply these two matrix, dimension of P we know that. So now the dimension of Q. So here now we have here 3 rows are there. We have 3 rows are there. So we have 3 rows are there, and we have 2 columns are there. We have 2 columns in Q, in the matrix Q. So that means dimension of Q is we have 3 rows and 2 columns. Now as you can see, these two matches with each other. So multiplication will be possible now. So the multiplication will be possible now. So that means the number of column we have is 3 here in the first matrix, and number of row also is 3 in the second matrix. So this one is matching with this one, so we can multiply. So that means we can multiply PQ. So now let's multiply PQ. So let us multiply PQ. Right. So before you multiply, you must know the dimension of the resulting matrix as well. So since this one should match with this one for the multiplication. Since this one number of column in the first matrix should match with number of row in the second matrix. So that means since this one and this one should match with each other to multiply P and Q. In that case, after you multiply, these one and these one will no longer be there. So that means these one will no longer be there, these one will also no longer be there. So the dimension, after you multiply the dimension of the matrix, so the dimension of the matrix will be 2 by 2. So after you multiply, you will have the resulting matrix. So if you multiply both matrix, if you multiply P with Q, the resulting matrix will have 2 by 2 matrix. The resulting matrix will have 2 by 2 matrix, since this one and this one matches with each other. Since this one and this one is matching with each other, these will no longer be there in the resulting matrix. So that means after we multiply, the resulting matrix will have dimension 2 by 2. That means 2 rows will be there, 2 columns will be there. So PQ will be like this. So 2 by 2 matrix will be there in the resulting matrix after you multiply. So now we will start multiplying. So before you multiply, remember, so we will take the first row first. So that means we will take the first row of the first matrix first. We will take the check my mouse movement. So we will take the first row of the first matrix. So we will take the first row of the first matrix first, and we will multiply with the first column of the second matrix. So I am saying again, we will multiply first row of the first matrix with the first column of the second matrix, with the first column of the second matrix. So like this way, but it should be done element by element. So that means we will multiply 4 with these 2. So that means first element should be multiplied with the first element, right? So that means I'm saying again, we will multiply first row with the first column of the first matrix, but it will be done element by element. So that means first elements will be multiplied by the first element. So like this way, 4 multiplied by 2, then we will have a plus. Now we will multiply second element with the second element, now we will multiply second element with the second element. So that means 0 multiplied by 1, 0 multiplied by 1. So 0 multiplied by 1 plus, now we will multiply this third element with the third element. So 3 multiplied by 8. So 3 multiplied by 8, right? So now again here, so we have already multiplied the first row, we have already multiplied the first row with the first column. So since we have multiplied first row with the first column, so the position will be, it will be there in the first row and also in the first column. So this is the first row and this is the first column. So since we have multiplied first row with the first column, it should be in the first row and the first column. Now we will multiply first row with the second column. So now we will multiply first row with the second column. So first row of the first matrix, first row of the first matrix, first row of the first matrix, and second column of the second matrix. So obviously the location will be, we will write it in the first row. That means since we are multiplying first row with second column, so we will be in the first row and in the second column. So this is the second column and this is the first row. So again we will do it element by element. So 4 multiplied by 5. So that means first element should be multiplied with the first element. So 4 multiplied by 5, then plus second element multiplied by second element. So second element multiplied by second element, that is 0 multiplied by 0, 0 multiplied by 0. In the exam you don't need to write it like that. So 0 multiplied by 0 is 0. You may just ignore this one. So now third element multiplied by the third element. So 3 multiplied by 2. So 3 multiplied by 2. So if you can write the first row carefully, then the remaining rows will be easier for you. If you can write the first row easily, then the remaining rows will be very easier for you. So in the remaining rows, what we will have, remember, this one will be there. So that means whatever you have after multiplication, so whatever you have after multiplication, these will sit as it is. So that means we will write like this, plus again this one. So I'm saying again, so this one will sit as it is in the second row. Again, so there will be a plus, and then again, so this one will sit as it is in the second row in all the remaining rows. So this one will sit as it is in the second row as well. So here again this one so that means this one will sit as it is in the second row, right? And then we will have plus 0. So that means this one will sit as it is in the second row, plus this one will sit as it is, this one will sit as it is in the third row, this one will sit as it is in the third row, right? So now what we will do before this one, so here we have already multiplied first row, with all the columns of the second matrix. We have already multiplied first row of the first matrix with all the columns of the second matrix. Now we need to multiply second row with all the columns of the second matrix. Now we need to multiply second row of the first matrix. Now we need to multiply second row of the first matrix with all the columns of the second matrix. So now we need to take the second row. Say in the second row we have 1, 9, 7. In the second row we have 1, 9 and 7. So in the second row of the first matrix we have 1, 9 and 7. So it will sit like that: 1, 9, 7. So here 1, 9, 7. So multiplication is done. Now we will just simplify. So here what we will see, so 4 multiplied by 2, 8. This is 0. 3 multiplied by 8 is 24. So 24 plus 8 we get 30. So here we will have 30. So sorry, not 30, not 32. So these will be 32. So that means 3 multiplied by 8, 24. 4 multiplied by 2, 8. So 24 plus 8 we got 32. Right. So what we will get here, we will get 20 plus 3 multiplied by 2, 6. So 26. 26. So what we will get here, $67. So we will get 67 here. So let me calculate it again. So 2 multiplied by 1, 2, 9 multiplied by 1, 9. So 9 plus 2 is 11. 11 and yes, it's correct. So now we will do this one. So now we will do this one. So this is 19. So this is 19. So that's the multiplication of PQ. That's the multiplication of P. Now let's do another multiplication. Now for example, here we have a matrix like 3 by 3 matrix. Here also 3 by 3 matrix. So now for example we have here is 5, 0, 2, 4, 9, 1, 6, 2, 7. So now here we have 1, 8, 2, 5, 1, 6, 1, 7, 3. So these are the two matrices we have. Now for example, these are the two matrices we have. We want to multiply these two matrices. So we want to multiply these two matrices. So here, so dimension of P is, we have 3 by 3 matrix, and here also we have 3 by 3 matrix. So we can, so these one matches with this one. So that means we can do the multiplication. So since these one matches with this one, the dimension of the resulting matrix, that means after you do the multiplication, so the resulting matrix will have a dimension like 3 by 3. So the resulting matrix will have a dimension of 3 by 3 matrix. So let us multiply PQ now. So let us multiply PQ now. So first of all, we will multiply the first row of the first matrix with the first column of the first matrix. So first of all, we will multiply first row of the first matrix with the first column of the first matrix. So we can write like that: 5 plus 0, 0 plus 2. Again here we can write 5 plus 0 plus 2. Here also we can write 5 plus 0 plus 2. So that means since we have since in the first row of the first matrix, we have 5 0 2, so we can write 5 0 2 in the first column, 5 0 2 in the second column, 5 0 2 in the third column. So now in the first place, at first we will multiply first row of the first matrix with the first column of the first matrix. First we will multiply first row of the first matrix with first column of the first matrix. So in the first column we have 1 5 1. In the first column we have 1 5 1. So we will write it like that: 1 multiplied by 5 multiplied by 1. So I am saying again, so we will multiply first row of the first matrix with first column of the first matrix, but element by element, right? So now, so we have already included the first column in here. So now here what we will do, we will move to second column, because we are now in the second column, so we will multiply elements of second column now. So in the second column we have 8 1 7. So serially we will write 8, so here 1, here 7, so 8 1 7, so 8 1 7 serially. So now we will move to the third column. So in the third column what we have, in the third column we have 2 6 3. So serially we will write 2 6 3. So this way we can write the first row. You have to write the first row very carefully. Now in the remaining rows, this one will cease as it is. So multiplied by 1, here also multiplied by 1. So and then we will have what? We will have plus multiplied by 5. So now this one will come. So multiplied by 5. So here also multiplied by 5, plus multiplied by 5 plus. So now this one will come, multiplied by 1. So multiplied by 1, so plus multiplied by 1. So these will sit as it is like that. So similarly here also we will write multiplied by 8 plus multiplied by 1 plus multiplied by 7. So this one will come here again. So multiplied by 2 plus multiplied by 6 plus multiplied by 3. So this one will come here again. Right? So multiplied by 2, multiplied by 6, multiplied by 3. This one will come again. So now as we have already multiplied first row, with all the columns of the second matrix, so now we will move to the second row. In the second row we have 4 9 1. So in the second row it will come serially 4 9 1. Here also, so here also 4 9 1. Similarly here also we will have 4 9 1. So now we will move to the third row of the first matrix. So in the third row of the first matrix we have 6 2 7. So serially it will come 6 2 7 6 2 7. So here also 6 2 7. So 6 2 7, 6 2 7. Right. Now we will just simplify. We will just simplify. So here 5 multiplied by 1 5 and 2 multiplied by 1 2. So 5 plus 2 is 7. So here 5 multiplied by 8 40 plus 7 multiplied by 2 14. So 40 plus 14 is equal to 54. 5 multiplied by 2 10 plus 2 multiplied by 3 6. So 10 plus 6 16. So now here 4 multiplied by 1 4, 5 multiplied by 9 45. So 5 multiplied by 9 45 plus 4 is 49 plus 1 is equal to 50. 4 multiplied by 8 32 plus 9 multiplied by 1 9. So 4 multiplied by 8 32 plus 9 is 41. 41 plus 7 48. So 48. This one 4 multiplied by 2 8 plus 6 multiplied by 9 54. So 54 plus 8. 54 plus 8 is 62 plus 3 65. So now here this one 6 multiplied by 1 6, 5 multiplied by 2 10. So 10 plus 6 16, 16 plus 7 23. Now this one 6 multiplied by 8 48 plus 2 50, 50 plus 49, 50 plus 49 is equal to 50 plus 49 is equal to 99. Now this one 6 multiplied by 2, 6 multiplied by 2 is 12. 6 multiplied by 2 12, that is 24, plus 3 multiplied by 7 21. So 24 plus 21 25 45. So that is PQ. That is PQ. Let us revise again. Let us check if the calculation is correct or not. So this is PQ. This is correct. So after we have done the revision, we have checked it. This one is correct. So this is PQ. So that means multiplication of two matrix P and Q. So this is the PQ. Right. So now for example, we have another question. Question is find 11 by 2. So find 11 by 2 PQ minus 2Q plus 4.5 P. So the question is asking us to find out this one. So if you want to find this one, what do you have to do? So 11 by 2. So 11 by 2 means 5.5. 5.5. So 11 by 2 means 5.5. And this is PQ. And this is PQ. So this is PQ. 11 by 2 means 5.5 multiplied by PQ. So this is PQ. This is PQ. Right. So minus 2 multiplied by Q. So this is Q. This is Q. So this is Q plus 4.5 P. So P. This is P. Right. This is P. So now we need to find the answer. Right. So remember. So this one is an isolated number outside the matrix. This one is an isolated number outside the matrix. So in matrix notation, this one is called scalar. In matrix notation, this one is called scalar. that is SCALER. So this one is called, in matrix notation, if you have a number outside the matrix, if you have an isolated number outside the matrix, we will call it scalar. Spelling is SCALAR. So this one is called scalar, right? So this one is in multiplication with this matrix. So this one is in multiplication of this matrix. So remember, so if you have a number with multiplication with a matrix, so what do you have to do? You have to multiply 5.5 with all the individual elements inside the matrix. So that means you have to multiply 5.5 with 7, you have to multiply 5.5 with 54, you have to multiply 5.5 with 16, and like that way with all the individual elements, right? So that means 5.5 multiplied by 7 is equal to, will be what? So 5.5 multiplied by 7 will be equal to what? Will be equal to multiplied by 7 will be equal to 38.5. So 5.5 multiplied by 7 will be equal to 38.5, will be equal to 38.5, right? So now 54 multiplied by 5.5. So that means all the individual elements should get multiplied by 5.5. So 5.5 multiplied by 54. 54 is equal to 297. So is equal to 297. 297. So similarly, this one should also get multiplied by 5.5. So this one should also get multiplied by 5.5. So 5.5 multiplied by 16 is equal to 88. Is equal to 88. Similarly, this one should also get multiplied by 5.5. So 5.5 multiplied by, so this one should also get multiplied by 5.5. So if this one is multiplied by 5.5, we will get 275. So we will get 275. Similarly, this one also should get multiplied by 5.5. So 48 multiplied by 5.5, 48 multiplied by 5.5 will be 264. Will be 264. So 264. Similarly, this one should also get multiplied by 5.5. So this one should also get multiplied by 5.5. So that means 65 multiplied by 5.5 is equal to 357. 357. So 357.5. 357.5. So similarly, this one should also get multiplied by 5.5. That is 126.5. So we will get 126.5. So similarly, this one should also get multiplied by 5.5. So that means this one should also get multiplied by 5.5. So 5.5 multiplied by 99 is equal to 544. $544.5. So that means if you multiply 5.5 with this 99, you will get 544.5. So similarly, this one should also get multiplied by 5.5. So this one should also get multiplied by 5.5. So 45 multiplied by 5.5, 45 multiplied by 5.5 is equal to 247.5. So 247. So 247.5, right? So this way we will multiply. This way we will multiply. Right, now as you can see, we have already multiplied. We have already multiplied this one. So we have multiplied 5.5 by all the elements inside the matrix. So that means all the elements inside the matrix has been multiplied by 5.5. Now we will do the same. So here we have a minus, and now what we will do, we will multiply these matrix with 2. So that means we will multiply all the elements inside the matrix by 2. So if you multiply 1 by 2, 1 by 2, that means 1. If you multiply 1 with 2, we will get 2. If you multiply these one with 2, we will get 16. If you multiply these one with 2, we will get 4. Here, if you multiply with 2, you will get 10. Here you will get 2. Here we will get 12. Here we will get 2. Here we will get 14. Here we will get 6. Right. So similarly, we will multiply these one also. So similarly, we will multiply these one also. So now if you multiply all the elements inside the matrix with 4.5, what we will do, what we will get, if you multiply it by, if you multiply these one by 5, what we will get, 22.5. We will get 22.5. So let me check. 5 multiplied by 4.5 is 22.5, and this one is 0. 4.5 multiplied by 0 is 0. This one we will get 9. This one we will get 18. This one we will get what? 4.5 multiplied by 9, we will get 40.5. We will get 40.5. So we will get 40.5. 4.5 multiplied by 9, we will get 40.5. Here we will get 4.5. 4.5. Here we will get what? 4.5 multiplied by 6, we will get 27. 4.5 multiplied by 4.5 multiplied by 6, we will get 27. Now 4.5 multiplied by 2, we will get 9. 4.5 multiplied by 7, 4.5 multiplied by 7, 31.5. Right. So now we will go for the addition and subtraction. Okay, so that means addition and reduction. So here there is a minus and there is a plus. So what we will do, we will process it element by element. Right. So how we will do it? So from these one we will deduct 2 because there is a minus here. So minus 2 plus 22.5. So plus 22.5. Similarly, from these one we will deduct, from these one we will deduct 16. From deduct we will deduct 16 plus, so from these one we will deduct 16 plus 0. Now from these one we will deduct, from these one we will deduct 4 and we will add 9. Similarly, from these one we will deduct 10, we will deduct 10 and we will add 18. We will add 18. So from these one we will deduct 2. We will deduct 2. So from these one we will deduct 2 and we will add 40.5. We will add 40.5. So from these one we will deduct, from these one we will deduct 12 plus 4.5 plus 4.5. So from these one we will deduct 2 and we will add 27. So from these one we will deduct 14 and 14 and we will add 9. So from these one we will deduct 6 and we will add 31.5. 31.5. So now let us calculate all this. So what we have here, so 38.5 minus 2, 38.5 minus 2, 38.5 minus 2 plus 22.5 which means 38.5 minus 2 plus 22.5, which means 59. So this is 59. Now this one, so if you deduct this one, 297 minus 16, so 291, that means 281. So 281. So this one, what we get, 88 minus 4, so that means 9 minus 4, that is 5. 9 minus 4, that is 5. 88 plus 5 is 89. So 89. So let me see. No, sorry. 9 minus 4. 9 minus 4 is 5. 88 plus 5 is 93. 93. So what we will have? We will have 93 here. So here what we will get? 275 minus 10. That is 265. 265 plus 8. 273. 283. So what we will get is 283. So we will get 83. So now what we will get here, so 18 minus 10, that means to say 8. So 275 plus 8, 275 plus 8, that means 283. So here we will get 283. So what we will get here, 264 minus 2, that is 62. So 62 plus 40, 62 plus 40, that means 302.5. So 302.5. So we will get 302.5, 302.5, right? So here what we will get, so here we will get 357.5 plus 4.5, that means 358 plus 4, that is 362. 362 minus 12, that is 350. We need to revise again, we need to check if we have done any mistake or not, right? So here what we will get, 27 minus 2, that is 25. So 25, that 50, 50, 51.5. So 151.5. 51.5. So here what we will get, so minus 14 plus 9, that is minus 14 plus 9, that is minus 5. So minus 5, if we deduct minus 5 from this one, what we will get, 39.5. We will get 39.5. 39.5, right? So what we will get here, so right, 248, 248, 249, 249 plus 30, 249 plus 30, 249 plus 30, that is 249 plus 30, 279. So 79 minus 6, 79 minus 6, that means 73, 273. So let me check again if you have done any mistake or not. Let me check, right? So I have checked it. It is absolutely correct. The answer is absolutely correct. So this way we can multiply two matrices, and also we can do addition and subtraction between matrices. So today, so here we have learned how to do multiplication between two matrices, and how to do addition, and how to add and subtract multiple matrices, right? So we have learned this today. Now we will learn how to find out determinant of a matrix. So now we will learn how to find determinant of a matrix. Determinant of a matrix. So determinant of a matrix, right? So determinant can be noted as D, right? So D is equal to, for example, we want to find out determinant of a matrix. Determinant of a matrix. So the matrix is, for example, the matrix that we have is, right? So for example, this is the matrix. So remember, if you want to find out determinant of a matrix, it has to be a square matrix. That means the size of the matrix should be, it should be a square matrix. That means number of column and number of rows should be same. number of row and number of column must be same. Right. So let's see. Right. So this is a matrix. So as I'm repeating again, if you want to find out determinant of a matrix, number of row and number of column should be same. So that means here, as you can see, we have 3 row and 3 column. So here we have 3 rows and 3 columns. So this is a square matrix. That means number of rows and number of columns are same. So this is a square matrix, and you can only find determinant of a square matrix only. So that means if you want to find out determinant of a matrix, it has to be a square matrix. So let's find out determinant of this matrix. So when we write matrix, we can write it inside a bracket or inside a parenthesis. But remember, when you write determinant of a when you want to find out determinant of a matrix, it has to be inside a modulus. So that means the matrix need to be inside a modulus. So this is a modulus. So I'm saying again, so this is the modulus sign. This is the modulus sign, right? So it has to be inside the modulus sign. So that means this is the, so when you put a matrix inside a modulus, we can understand that we want to find out determinant of that matrix. So to find out determinant of a matrix, first we need to take the first element of the first row. First element of the first row. So we will take the first element of the first row. Right. So when you take first element of the first row, in that case, that row, we need to ignore that row. And also we need to ignore that column. Check my mouse movement. So as we have taken the first element of the first row, so these row need to be ignored. As we have taken first element of the first column, this column also need to be ignored. So we will ignore first row, and we will ignore first column. So we will be left with what? We will be left with 9 1 3 1. So I'm repeating again, since we have taken the first element of the first row, so we will ignore this row. So we will ignore this row, and also we will ignore this column. So we will be left with 9 1 3 1. So 9 1 3 1 minus. So this is the formula. For the second element, it has to be minus. The second element is what? Second element is 0. So second element is 0. If the second element is 0, you actually don't need to write. But since you are learning, I am showing you. That's why I am showing you. So if you take these element, because this could be any other element also. So in that case, you have to take that element. So since you are studying, since I am teaching you for the first time, that's why I am writing this one. But if you have a 0 here, you can just ignore. You don't have to write it actually, right? So now we will take these one. So that means second element of the first row. Since we are taking second element of the first row, so we will ignore first row. And since you are taking these element, so you will ignore the second column also. So I'm repeating again, since we are taking these one, so we will ignore first row and we will ignore second column. So if you ignore this, what we will have in our hand? So we will have in our hand is, so I'm saying again, since you are taking these one, we will ignore first row and we will ignore second column. So we will be left with 7 1. So we will be left with 7 1 0 1. 7 1 0 1. So we will be left with 7 1 0 1. So I'm repeating again, since we are ignoring first row and the second column, we will be left with 7 1 0 1. 7 1 0 1 plus. So now we will take these one. So now we will take these one. That means the third element of the first row. right? So when you will take third row of the third element of the first row, now we will take third element of the first row. Since we are taking third element of the first row, first row will be ignored, and the third column also need to be ignored. So that means we will ignore first row and we will ignore third column. So we will be left with 7 9 0 3. So we will be left with 7903. So let me revise again. 2 9131 correct, 0 7101 correct, and these one 7903 correct. So now what we will do, right? So now we will calculate these one first. So first these 2 multiplied by, so we will multiply right diagonal element first. So we will multiply these one with these one. So we will multiply right diagonal. Right diagonal means this one. So right diagonal means this one. So we will multiply 9 with 1. So if you multiply 9 with 1, 9 multiplied by 1 minus. Now we will multiply left diagonal elements. That means we will multiply this 1 with this 3. So we will multiply 1 and 3. So 1 multiplied by 3, bracket close. So in the exam you don't need to write this step. You can just multiply and write it directly. Since you are doing it in the first time, that's why I am showing you. So here minus 0 multiplied by something. So 0 multiplied by something. As you know that 0 multiplied by something is 0. That's why we will just ignore this one. Plus 4. Now what we will have? So we will multiply again the right diagonal element first. So we will multiply 7 with this 3. So 7 multiplied by 3 minus 9 multiplied by 0. So what we will have? We will have 2 multiplied by 9 minus 3. So 9 minus 3 plus 4. This one what we will get? 3 multiplied by 7, that is 21, and this one is 0. So what we will have? 9 minus 3 is 6. 6 multiplied by 2, 12, plus 4 multiplied by 21. 4 multiplied by 21 is 84. That is 84 plus 12 is 96. So that's the determinant of this matrix. So determinant of this matrix is 96. So let me check if the answer is correct or not. Yes, so the answer is correct. Answer is fully correct, right? So answer is fully correct, right? So now we will learn how to find inverse of a matrix. So inverse of a matrix. So question is find inverse of following matrix using cofactor matrix method. So find inverse of the following matrix. Find inverse of the following matrix using cofactor matrix method. So we can find inverse of a matrix. Using cofactor matrix method or Gauss-Jordan matrix method. So here today I will show you how to find inverse of a matrix using cofactor matrix method. Right. So suppose the matrix that we have here is, again remember, you can only find inverse of a square matrix. You can only find inverse of a square matrix only. That means the number of row and the number of column has to be same, right? So for example, the matrix that we have here is right. So for example, this is the matrix that we have. So this is the matrix we have. Excuse me. So this is the matrix we have. For example, we have a, let me make it more complex. Let me see. For example, here we have minus, maybe let's see. Here also we have minus, and like that. So for example, we want to find inverse of this matrix. We want to find inverse of this matrix using cofactor matrix method, right? So if you want to find inverse of a matrix using cofactor matrix method, the step 1, in the first step, step 1, you need to find determinant. You need to find determinant of that matrix. So you need to find determinant of that matrix. So that means D is equal to, so we need to find determinant of the matrix. So we know that determinant of a matrix is shown inside a modulus, right? So we need to find determinant of this matrix. So D is equal to what? So here again we will take the, so if you want to find determinant of a matrix, we will take the first element of the first row first. So we will take the first element of the first row, and so since we have taken first element of the first row, these row need to be ignored, these column also need to be ignored. So these row need to be ignored, these column need to be ignored. So we will be left with minus 2, 5. So we will be left with minus 2, 5, 9, 3. So I'm repeating again. So in the if you are, so to find out determinant of a matrix, we need to take the first element of the first row. So since we are taking this one, so we will ignore this row, we will ignore this column. So we will be left with minus 2, 5, 9, 3. Minus 2, 5, 9, 3. And after that, there is a minus in the formula. This is the minus for the formula, right? This is the minus for the formula. And now we will take the second element. So in the second element there is another minus. So what we will do, we will write it inside a bracket. So maybe you can write it directly also, because this is the minus of the formula, and this is the minus with the element. So minus a plus, you can write directly plus also. But since you are learning at this level, I am not doing it directly, right? So now we are taking the second element of the first row. Since we are taking this one, the first row need to be ignored, the second column need to be ignored. So we will be left with 1, 5, 2, 3. So 1, 5, 2, 3. So 1, 5, 2, 3. And then we will have a plus. Right? So now we will take this one, 4. So right. So when we will take this 4, we will take this 4. So we will, since we are taking this one, we will ignore the first row, we will ignore the third column. So I'm repeating again. So we will ignore the first row, we will ignore the third column. So we will be left with So what we will have, so we will be left with, oops, sorry, so we will be left with what? 1 minus 2 2 9. So I'm repeating again, since we have taken these one, so we will ignore the first row, we will ignore the third column, so we will be left with 1 minus 2 9. So 1 minus 2 2 9. So we will be left with, so we will ignore the first row, we will ignore the third column, we will be left with 1 minus 2 2 9. So 1 minus 2 2 9. Now let us calculate. So 8 multiplied by, so now we will multiply the right diagonal element first. So we will multiply these one with these one. So minus 2 multiplied by 3, that means minus 6, and there is a minus in the formula. So minus, now we will multiply, so this is the minus. Before you multiply the left diagonal element, you need to put a minus. So now we will multiply this 5 with this 9. So 5 multiplied by 9 is 45. So now this one, so here now this one, so minus a plus, so we will have a plus 1. So 1 you don't need to write actually. So now we will multiply again the right diagonal element first. We will multiply right diagonal element first. So 1 multiplied by 3, we will get 3 minus, now we will multiply this 5 with this 2. So if you multiply these two, 5 multiplied by 2, that is 10, plus 4. Now we will multiply this 1, we will multiply this 1 with this 9. So 1 multiplied by 9, that is 9, minus, this is the minus of the formula. Now we will multiply these one with these one. So with these one with these one. So if you multiply these one with these one, we will get, if you multiply these one with these one, you will get minus 4. We will get minus 4, and there is another minus here. We will get minus 4, and there is another minus here. So minus a plus. So let me write it actually. Let me write another step here. So here we will get minus 4 like this. Sorry, like this. I'm saying, repeating again. So first of all, we will multiply 1 with this 9. So 1 multiplied by 9, that is we will get 9. And then before we multiply the left diagonal element, there is a minus in the formula. So now we will multiply left diagonal element. That means we will multiply this minus 2. We will multiply this minus 2 with this 2 So we will get minus 4. We will get minus 4. Right. So now what we will get? So here what we have, minus 45 minus 6. So we will, that is minus 51. So minus 51 multiplied by 8, that is minus 51 multiplied by 8, that is 408. Minus 408. So minus 51 multiplied by 8, that is minus 408. Now these one, so 3 minus 10, that is minus 7, minus a plus a minus, that is minus 7. So 3 minus 10, that is minus 7. 3 minus a minus 7. Now these one, what we will get here? So minus a plus, that is plus 4. So plus 4 plus 9, that is plus 9 plus 4. 9 plus 4, that is 13. 9 plus 4, that is 13. 13 multiplied by 4 is 52. So plus 52 is equal to what we will get? Minus 408 minus 7 plus 52 is equal to minus 363. Minus 363. So that's the determinant. That's the step 1. So if you want to find inverse of a matrix, using cofactor matrix method. If you want to find inverse of a matrix using cofactor matrix method, in that case, in the step 1 you need to first find out determinant. Step 1 is you need to find determinant of the matrix. You need to find determinant of the matrix, right? Now in the second step, step 2, you need to find cofactors. You need to find cofactors of the matrix. So in the second step you need to find cofactor of the matrix. So right, so now in the step 2 we will find cofactors of the matrix. So let us name the elements of the matrix first. So let us suppose the name of the matrix. Suppose the name of the matrix is A. Suppose name of the matrix is A. So this is the first element. Right? This element is in the first row and also in the first column. This element is in the first row and also in the first column. Right? So that means let us name the element. So name of the matrix is A, and this element is this is the first row. Since this is the first row, the name of the element will be what? This one indicates the row address. So since we are in the first row, it will be 1. Since now we are in the second row, that's why these will be 2. So now we are in the third row, that's why this one will be 3. So the first number indicates row address. So first number indicates row address, and since we are in the first column, this will be 1. Since we are in the second column here, this is in the second column, this will be 2. Since this one is in the third column, this will be 3. So like that way we need to name all the elements with their address. So this is A11, this is A12, this is A12, this is A22. That means this element is in the second row and second column. This element is in the second row and also in the second column. This way we will name all the elements, and we have total 9 elements here. And remember, so if you want to find cofactor of a matrix, the sign of the first element will be plus. The sign of the first element should always be plus, and the second element will be minus. So since this is plus, all the adjacent element will be opposite. So since this one is plus, this one need to be minus. That means opposite. Again, since this one is plus, this one should be minus. That means you cannot have plus in the adjacent. You cannot have the same sign in the adjacent cell. You cannot have the same sign in the adjacent element. Right? For the adjacent element, you cannot have the same sign. Since this one is plus, it will be always plus. The first element should be always plus. Since this one is plus, this one should be minus. That means adjacent cell should not have same sign. Since this one is plus, this one has to be minus. And again, since this one is minus, this one should be plus. Alternate sign should be there. Again, since this one is plus, this one has to be, since this one is minus, this one has to be plus. That means opposite. That means adjacent cell cannot have the same sign. So in this way, you can see, if you put the sign, you will see that all the right diagonal elements will be plus, and all the left diagonal elements will be plus. So that means you will see that all the diagonal elements, that means all the diagonal elements will be plus and the remaining element will be minus. So I'm saying again, all the right diagonal elements and left diagonal elements will be plus and the remaining elements will be minus. Now we need to fill out the inside elements here. So that means here, so as I said, the first element should be plus. So now we need to find out the cofactor of the first element. Now we need to find out the cofactor for the first element. It's almost like determinant. It's almost like finding determinant. So here only difference is when you find determinant, we will multiply by the element. But here when you want to find cofactor, we will not multiply by the element. We will only find the cofactor. So when you want to find, so this is the first element. So that means we want to find cofactor of the first element. So we want to find cofactor of the first element. This is the first element of the first row. This is the, as you can see from the address, first row, first column. So that means we want to find out the cofactor of this one. So when you want to find cofactor, when you want to find out cofactor of this one, we will ignore the first row, we will ignore the first column. So that means we will ignore first row, first column. We will ignore first row, first column. So from the address you can see, so we will ignore first row, first column. So we will ignore first row. So we will ignore first row and first column. So we will be left with minus 2593. So that means this one. Sorry, excuse me. So that means, so I'm repeating again, if you want to find cofactor of this one, we will ignore the first row, we will ignore the first column. So that means we will be left with minus 2593. So minus 2593. It's almost like determinant. But only difference is here we will multiply. When you want to find determinant, we will also multiply it by the element itself. But here we will not multiply it by the, here 8 will not be there, right? Only plus should be there. Now this one, now we will ignore first row, second column. Now we will ignore first row, second column. That means we want to find out the cofactor of this one. That means we will ignore first row, second column, right? We will ignore the first row and we will also ignore second column. We will ignore first row and we will also ignore second column. So we will be left with 1 5 2 3. So that means we will be left with this one, 1 5 2 3. So we will be left with 1 5 2 3. But as I said before, here when you want to find out determinant, we will write this one. But here we will not write this one. Here only sign should be there. So similarly, now we want to find out the cofactor of this one. So we will ignore this row, we will ignore this column. So we will be left with 1 minus 2 2 9. So that means 1 minus 2 2 9, right? So 1 minus 2 2 9. So now we want to find out the cofactor of second row, first column. So we want to find out the cofactor of the second row, first column. So that means we want to find out the second row, first column. That means this one. So that means we want to find out the cofactor of this one. So as usual, we will ignore what? We will ignore second row, first column. Second row, we will ignore second row and we will ignore first column. That means we want to find out the cofactor of this one. So this is in the second row. This is in the second row. We will ignore second row. And this is in the first column, we will ignore first column. So what we will have in hand, so we will be left with, I'm saying again, we will ignore second row, we will ignore first column, so we will be left with minus 1493. So minus 1493. So minus 1493. So minus 1493. So we will be left with minus 1493. Minus 1493. So minus 1493. Minus 1493. Right. Minus 1493. Now this one. So now we want to find out. Now we want to find out the cofactor of these element. Cofactor of these element. That means second row, second column. So now we want to find out the cofactor of these one. Second row, second column. Second row, second column. That means we will ignore second row. We will ignore second column. So we will be left with 8, 4, 2, 3. So we will ignore this. We will ignore this row. We will ignore this column. So we will be left with 8, 4, 2, 3. So 8, 4, 2, 3. So 8, 4, 2, 3. Right. Now we will find out cofactor of this one. We will find out cofactor of this one. So if you want to find out cofactor of this one, we will ignore this row. We will ignore this column. So we will have what we will have in hand. 8 minus 1, 2, 9. So 8 minus 1, 2, 9. So we will have 8 minus 1, 2, 9. So we will have 8 minus 1, 2, 9. So I am repeating again. So if you ignore this one, if you want to find out cofactor of this one, we will ignore this row, we will ignore this column. So we will have what? 8 minus 1, 2, 9. So 8 minus 1, 2, 9. Now we will move to third row, first column. Third row, first column. Right. Third row, first column. Right. So that means we want to third row, first column. Third row, first column. That means we want to find out the cofactor of these element. Cofactor of these elements. So that means we will ignore the third row. We will ignore third row. We will ignore first column. So what we will have in our hand? Minus 1, 4, minus 2, 5. Minus 1, 4, minus 2, 5. So we will have minus 1, 4. I'm saying, let's see. So we will ignore this row. We will ignore this column. We will have what? Minus 1, 4, minus 2, 5. Minus 1, 4, minus 2, 5. So minus 1, 4, minus 2, 5. Right. So minus 1, 4, minus 2, 5. So minus 1, 4, minus 2, 5. Right. So now we will find out cofactor of these elements. So cofactor of these element. So obviously we will ignore this row. We will ignore this column. So what we will have in our hand? We will ignore this row. We will ignore this column. We will have 8, 4, 1, 5. We will have 8, 4, 1, 5. So 8, 4, 1, 5. So 8, 4, 1, 5. So we will have 8, 4, 1, 5. So 8, 4. So this one out. So 8, 4, 1, 5. Right. So now we will find out cofactor of these one. We will find out cofactor of these one. So we will ignore this row. We will ignore this column. So what we will have? 8 minus 1, 1 minus 2. 8 minus 1, 1 minus 2. 8 minus 1. So 8 minus 1, 1 minus 2. 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 Right. So now we will calculate. So now we will calculate. So now first of all, let us calculate these one. Let us calculate these one. Right. So if you calculate these one, is exactly like determinant. So we will multiply the right diagonal element first. So we will multiply these one. We will multiply right diagonal elements. So we will multiply these one with these one. So minus 2 minus 2 multiplied by 3. So there is a plus here. There is a plus here. So here minus 2. We will multiply right diagonal elements. So minus 2 multiplied by these 3. Multiplied by these 3. So we will have what? Minus 6. Minus 6. And there is a minus before you multiply left diagonal element. Now we will multiply left diagonal element, that means this one multiplied by this one. So that means 45. 5 multiplied by 9, that is 45. That means minus 45 minus 6, that means minus 51. So minus 51. Right. So that means minus 51. That means minus 51. Right. Now let us calculate these ones. So minus bracket, there is a minus here before, so there is a minus here before, that's why minus. So now we will multiply inside things. First of all, we will multiply the right diagonal elements. So we will multiply the right diagonal elements first. So we will multiply 1 with these 3. We will multiply 1 with these 3, that means 3. So that means we will multiply this 1 with this 3, that is 3 minus, now we will multiply left diagonal element, right. So 5 multiplied by 2, that is 10. So 1 multiplied by 3, that is 3 minus 5 multiplied by 2, that is 10, right. So that means what we will get, sorry, so what we will get is, so here 3 minus 10, that is minus 7, minus 7 is a plus 7, minus 7 is a plus 7, right. So that's what we will get here. So is equal to, now we will calculate these ones. So here is a plus, and now as I said, first we will multiply right diagonal elements. So first we will multiply this 1 with this 9. So 9 multiplied by 1, that is we get 9 here, right. And then this is the minus from the formula. So this is a minus from the formula, and now again there is a, now we will multiply these one, the left diagonal element, this one multiplied by this one, this one multiplied by this one, that is minus 4. That is minus 4. That is minus 4. That means here we have minus 4, right, like this. So that means I'm saying, repeating again, first of all we will multiply these one with this one, that means right diagonal elements. 9 multiplied by 1, 9, and this is the minus of the formula. And now we will multiply these one, we will multiply these one with these one. So minus 2 multiplied by 2, that is minus 4. So minus a minus a plus 4, we can write directly also here, doesn't really matter. That is, here what we will get, minus a minus a plus 4. So 9 plus 4, that is 13. That is 13. Now we will calculate this one. Now we will calculate this one. There is a minus. There is a minus before this one. There is a minus before this one, so we will write the minus. Now we will multiply right diagonal elements first. This one multiplied by this one. So that is minus 3. Minus 3. And this is the formula. This is the minus of the formula. Before you multiply left diagonal element, this is the, you need to put a minus, right. So 4 multiplied by 9, that is 36. So if you calculate, what we will get, minus 36 minus 3, that is minus 39, minus 7 is a plus 39, plus 39. Right, so now let's do this one. We have a plus there, bracket. First we will multiply right diagonal elements. So first we will multiply this 8 First we will multiply this 8 with this 3, so 8 multiplied by 3, that is 24, minus, now we will multiply left diagonal elements, 4 multiplied by 2, that is 8. Right, so sorry, right, what we will get, so 24 minus 8 is 16, So now let's do this one. So there is a, you can see there is a minus here, so first we need to write that minus. So there is a minus here, we will write that minus, so then bracket. Now again we will multiply the right diagonal elements first. 8 multiplied by this 9, so 8 multiplied this 9, 8 multiplied by this 9, so 8 multiplied by this 9, that means 72. 72 minus, say, that means, let me write this way like that, so minus, this is the minus of the formula. Before we multiply left diagonal elements, we need to put a minus. Now this one, so this minus 1 multiplied by this 2, we will get minus 2, so minus 2. You can write it directly also if you are expert. So minus a plus, you can write directly plus also here. Is equal to what we will get, so 72 minus a plus 2, 72 plus 2, that is 74, that is minus 74. So 72 plus 2, that is 74, and there is a minus before, that is minus 74. Now this one, there is a plus bracket. First of all we will multiply the right diagonal elements, so minus 1 multiplied by 5, that is minus 5, and this is the minus of the formula, this is the minus from the formula, right? And now we will multiply left diagonal elements, 4 multiplied by this minus 2, so 4 multiplied by this minus 2, that is minus 8, as I said before, you can write directly plus also there, doesn't really matter, right? So here what we will get, minus a plus 8, so 8 minus 5, that is 3, 8 minus 5, that is 8 minus 5, we will get 3 here. Is equal to, so there is a minus before this one, so we will put the minus bracket. First we will multiply right diagonal elements, that is 8 multiplied by this 5, that is 5 multiplied by 8, that is 40, minus 4 multiplied by 1, that is 4. Right. So we'll do minus 40 minus 4, that is 36, that means minus 36. Right, now is equal to plus bracket. First of all we will multiply this 8 with this minus 2, right? So 8 multiplied by minus 2, that is minus 16, and this is the minus from the formula. This is the minus from the formula. Now we will multiply these one left diagonal elements. Minus 1 multiplied by 1, that is minus 1, that is minus 1. So is equal to what we will get. So minus 16 minus a plus 1. So minus 16 plus 1. So minus 16 plus 1, that is minus 15. So minus 15. So what we will get? Minus 15. Right. So these are the cofactors. These are the cofactors. So that means cofactor matrix. Cofactor matrix is equal to, so the cofactor matrix will be equal to, so these are the cofactors of the first row. So these are the cofactors of these are the cofactors of the first row. So what we have in the first row, these are the cofactors of the first row. That is what we have in the first row. Minus 51 7 13. So minus 51 7 13. So minus 51 7 13. So now in the second row, so what we have in the second row, in the second row we can see 39 16 minus 74, 39 16 minus 74. So 39 16 minus 74. So now the third row. In the third row, the cofactors are 3 minus 36, 3 minus 36, and minus 15. So this is the cofactor matrix. So these are the this is the cofactor matrix. Now in the step 3, in the step 3 we need to find adjoint matrix. Adjoint matrix. So adjoint matrix is equal to transpose of the matrix. Adjoint matrix is equal to transpose of the matrix. So transpose of the matrix, that means transpose of the matrix. Adjoint matrix means transpose of the matrix. That means rows will become column, column will become row. So that means adjoint matrix is equal to, this is the cofactor matrix, this is the cofactor matrix. Let me write it so that you don't get confused, so that you can remember. So transpose adjoint matrix means transpose of the cofactor matrix. That means these one. So that means what we have, what we get from the cofactor matrix, we will transpose it. T means transpose. That means the rows will become, that is the rows will become column, columns will become row. So what we have in the column, these will become row. So minus 51. So this is the first column, so minus 51, these will become row. 39 3. So as you can see, so this is the first column, it will become first row. So that means adjoint matrix is transpose of the cofactor matrix. That means transpose means row will become column, column will become row. So that means this is the first column of the cofactor matrix. So this means first column will become first row. So that means minus 51, 39, 3 will become the first row. So now second column will become the second row. Second column, this is the second column, this will become the second row. So what we will have, 7 16 minus 36. So this is the third column, this will become the third row. So 13 minus 74 minus 15. So this way rows will become column, columns will become row. 13, let us revise. Right, 3 minus 36 minus 3. Right, perfectly correct. Now step 4. Now the step 4, the final step. Step 4, in the step 4 we will find the inverse matrix. So we will, in the step 4 we will find the inverse matrix. So remember, inverse matrix is equal to adjoint matrix divided by D, divided by the determinant. So that means inverse matrix is equal to adjoint matrix divided by D. So inverse matrix is equal to adjoint matrix divided by D, right? So adjoint matrix, this is the adjoint matrix, so this is the adjoint matrix divided by D. D is the determinant. So D is the determinant. So you can see the determinant, we have calculated it before. Determinant is minus 363. Determinant is minus 363. Right. So determinant is minus 363 is equal to. Right. So now what we will do? So this is again a scalar. This is a scalar. That means this is an isolated number. This is an isolated number outside the matrix. So we will call it scalar. Right. So when you do multiplication with a scalar, we will multiply all the individual elements by that scalar. Similarly, when you want to divide a matrix by a scalar, you need to divide all the individual elements of the matrix by that scalar. So that means we will divide all the individual elements inside the matrix by 363. So that means what we will have is these one need to be divided by minus 363. Again, like that way, all the elements need to be divided by minus 363. So all the elements need to be divided by minus 363. So again, these one also need to be divided by. So in the exam, you don't need to write it like that. You can just divide using your calculator and write the answer here, right? So since you are learning for the first time, I am showing you all the possible steps so that you don't get confused. In the exam, you don't need to write all these steps. You can just divide using it. That means you can just divide all the elements by 363 and write it in decimal points. Similarly, these one also need to be divided by minus 363. So these one also need to be divided by minus 363. We will divide these one minus 363. We will divide these one minus 363. Right. So what we will have is equal to, now let us divide all this. Now let us divide all this and write the answer. So let us divide all this and just write the answer. So here what we will divide, so minus minus and minus will cancel each other out. So we will divide 51 divided by 363. So 51 divided by 363 is equal to 0.1404. Right. Now we will divide 39 divided by minus 363. So what we will get, minus 0.1074. 0.1074. So 0.1074. Now let us divide these one. So 3 divided by 3 divided by minus 363. So 3 divided by minus 363. We got the answer in power. So we will press shift ENG and again shift ENG and then we will get the answer. So minus 0.0082. Right. Right. So now we will divide 7 divided by minus 363. So 7 divided by minus 363 is equal to minus 0.0192. Minus 0.0192. Right. Next one. 16 divided by minus 363, that is minus 0.044. Next one. So here minus and minus will cancel each other out. So we will divide 36 divided by 363. So we will divide, right, we will divide 36 divided by 363. So what we will have, 0.0991. 0.0991. So next one. So if you divide 13 divided by minus 363, what we will get, minus 0.0358 minus 0.0358. So minus will cancel each other out. So what we will have, minus 74, that is 74 divided by 363. So right. So what we will have, 0.2038. Remember, you need to write up to 4 decimal point. You need to write up to 4 decimal point. So 15 divided by 363. So what we will get, 0.0413. 0.0413. So that's the answer. That's the inverse matrix. So inverse matrix is equal to these one. So inverse matrix is equal to these one. So that's the answer. That is the inverse matrix. Inverse matrix is equal to, so here inverse matrix is equal to these one. That means the initial matrix was A. That means initial matrix was A. This was the initial matrix. So here so this is the sign of the inverse matrix. So this was the original matrix and inverse mean power minus 1. So the answer is this one. Answer is this one. Right. So let me check whether the answer is correct or not. Yes, the answer is absolutely correct. I have checked it. The answer is absolutely correct. So that's the end of today's session.